Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Open Source Multimedia Framework, FFmpeg. Our guest speaker today is Mr. Apoor Sangal, Technical Manager, ERS OEM CE Mobility at HCL Technologies. Apoor has 9 years of industry experience in the embedded system domain. He has extensive experience in board bring-up, firmware development, bootloader customization and importing the Linux OS, device drivers, multimedia framework, and user application development in embedded systems. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Apoor. No voice from your end. Can you listen to me?
Yeah, hi, I've joined.
Hello? Yeah, Apoor. Can you hear
Yeah,
me?
I've joined.
Okay,
Yeah, I can hear you.
so you can start.
So should I go through the agenda once again or?
Yeah, you have to start it all together because we couldn't listen to you at all.
Okay. Hello everyone. Welcome to this webinar on Open Source Multimedia Framework, FFmpeg. Agenda for today is overview of open source multimedia framework. In this, I'll talk about what is multimedia framework and why it is required. I'll also talk on the advantages of open source. The second topic will be overview of FFmpeg. I'll give an introduction to FFmpeg, various command line tools and libraries that it has to offer, how FFmpeg can be compiled on a Linux operating system, what are the different use cases of FFmpeg. The third topic in today's agenda is integration of hardware codecs in FFmpeg. In this, I will present different ways of leveraging the hardware codec using FFmpeg. I'll talk about some typical issues that developers face while integrating hardware codecs into FFmpeg. The last topic for today is going to be advantages of using hardware codecs over software codecs. In this, I'll be presenting some examples of usage of hardware codecs that has resulted in better CPU utilization and better performance while doing playback and transcode through FFmpeg. Let's go to the first slide. Before starting with the first slide, there are a couple of things which I will not be covering in today's webinar, and this is just to set the expectations right. I will not be talking about audio and video compression techniques. I'll not be talking about the FFmpeg command line parameters and the various options that you can use with FFmpeg command line. Okay, let's go on the first slide. Why multimedia framework is required? All of us would have faced a scenario when a multimedia content does not get played using a certain multimedia player, while the same content plays with some other multimedia player. The usual error message we get are file format not supported, codec not found, etc. Audio video compression techniques are getting evolved at a very fast pace. New standards are getting introduced. For example, a new video compression standard is under development, which is called as HEVC or H.265. It is a successor to H.264 or MPEG-4 AVC. Every standard has its own algorithm for encoding and decoding. Multimedia application developers needs to develop new libraries to support multimedia components like audio, video, speech, etc. This constantly changing environment will require a huge effort to change existing applications to support new standards. Hence, a framework is required to make applications compatible with multiple standards. Moving on to the next slide. So what is multimedia framework? The figure shown over here is an example of a generic multimedia framework architecture. At application layer, there are multimedia player applications like XBMC, MPlayer, VLC, etc. These multimedia applications will be interacting with multimedia framework. In order to make use of available hardware codecs, the framework communicates with codec device drivers, and device drivers controls the available hardware codecs. In scenario where hardware codecs are not available, multimedia framework comprises of software codec libraries. These software codec libraries can cater to multimedia applications. So moving on to the next slide. Multimedia framework is a software framework that provides functionalities to perform media processing and an interface for applications to use this framework. The media processing modules are independent of applications using the framework. So it is a generic framework. Any application making use of this framework can leverage the capabilities. It offers a complete standard APIs and a modular architecture for easy customization. The customization can be done as per the requirement, like if a developer wants to add a new audio format, new video format, so all these customizations can be done with the standard set of APIs that framework gives to the developer. The framework can be optimized in terms of memory usage or CPU performance. This will depend upon the kind of target hardware. So these performances will be different depending upon different target. Multimedia frameworks are typically used by media players for decode, playback, audio video editors, for transcoding applications, for providing streaming functionalities, and so forth. So we have talked about what is a multimedia framework. Now, why are we going for open source? What are the advantages that open source gives over proprietary software? So open source means that the source code of the software is made available to open source community. This enables developer to modify and redistribute the source code without paying royalty or fees. It gives developers a significant advantage in developing applications on top of multimedia framework. Just imagine how much the life of a developer will become simpler if he doesn't have to worry what kind of a license is it. There are many open source multimedia frameworks available in open source community. Two of the most popular open source multimedia frameworks right now are FFmpeg and Gstreamer. So I'll be covering FFmpeg today in this particular webinar. Both of these are licensed under LGPL. However, FFmpeg has certain optional parts that are covered under GPL. Although developers can leverage the source code, but they should be careful while adding their own components into the source code, as they need to use correct set of headers. They should configure their source code either as LGPL or GPL, and then use the correct set of headers and release the source code to open source community accordingly. Now, once we have understood what is multimedia framework, let us try to have an insight about FFmpeg. So moving on to the next slide. So I'll give an introduction to FFmpeg. What is FFmpeg? FFmpeg is a multimedia framework developed in C language. It is originally developed for Linux platform, but now FFmpeg can be compiled and used over Microsoft Windows as well as Mac OS. FFmpeg is a very diverse multimedia framework. Almost every codec which is in existence today is supported by FFmpeg. It is application independent. It facilitates developer to integrate software and hardware codec libraries. Let us take an example of H.265, the new video codec standard which is coming up. So any developer who is familiar with H.265 standard can make its own library and integrate into the FFmpeg. It enables application program providers an option of not shipping the codec libraries along with their players unless it is proprietary codec. The application providers need not worry about the codec libraries, as codec libraries are part of FFmpeg framework. So they can just release their media application and let FFmpeg take care of all the encoding and decoding needs. As a lot of multimedia players are dependent on FFmpeg, they are using FFmpeg. So the memory utilization goes low because there is no need to have multiple copies of a codec library. So the other features of FFmpeg are a developer can integrate a hardware codec. So it can leverage hardware acceleration features which are provided by the platform. Hardware acceleration can be provided by using GPU, which is existing in the platform. The hardware acceleration supports enhanced performance by reducing the CPU utilization for multimedia processing. Main functionalities offered by FFmpeg. The main functionalities are a user can decode, a user can encode, it can do transcoding, it can do a muxing, demuxing, streaming, and filter. I've listed just a few of the features which FFmpeg supports, but these are the main ones. So moving on to the next slide. FFmpeg command line tools. Basically, FFmpeg binary is used for for transcoding, that is conversion of multimedia files from one format to another format. It primarily uses libav codec library to access various codecs that it has to offer. It also comprises of a basic multimedia player, which is called as FFplay. So FFplay in turn invokes FFmpeg libraries for doing a decode and a playback. For rendering purposes, it uses SDL library. So in a way, SDL becomes a prerequisite. If a user wants to play a file using FFplay, it has to have SDL installed in their machines. FFprobe, it is a multimedia stream analyzer. It gathers information from multimedia stream headers and prints it in a readable format. FFserver, this is again a very important tool that FFmpeg has to offer. It is a multimedia server. It is used for streaming, broadcasting of audio-video content over the network. It makes use of FFmpeg libraries to get input streams and feeds it to them. FFserver can be used to stream data over RTP, RTSP, or HTTP. So it supports different kind of internet protocols. Moving on to the next slide. FFmpeg libraries. FFmpeg comprises of following libraries. The first one is libav codec. Libav codec supports multiple decoders and encoders for different multimedia streams. It is in the form of a shared library, so this gives a favorable usage environment. libav util. It contains utilities and routines which are common to different parts of FFmpeg. libsw scale. It consists of routines for video resizing, conversion of image format, and color space. libsw resample. It consists of routine changing sampling rate, format conversion, channel layout of audio samples. There could be different channels like stereo, mono, 5.1, 7.1. So libsw resample takes care of all those needs. libav format. It consists of routines to demux and multiplex various multimedia container formats. So whenever you try to do a playback, before doing a decode, demuxing needs to be done. So libav format takes care of that. libav device. It provides routines for audio video capture from input device and render the audio video to output device. So libav device gives an option of AV capture. So nowadays AV capture is becoming a very common phenomena with streams coming from a webcam or a USB camera. So libav device can be used for that particular feature. libav filter. So with this you can add watermarks and logos to your stream. So this kind of functionality can be taken care of by using libav filter. So moving on, now how this FFmpeg source code will be compiled, or from where this can be fetched. So basically FFmpeg source code has been developed with Git. Git is nothing, it's just a source version control system. So a user can retrieve FFmpeg source code using Git client. So a user has to install Git client on his or her Linux machine and can just do a git clone. I've shared the URL. From this URL a user can just do a git clone and it will be able to retrieve the FFmpeg source code. So once you have downloaded the source code, you need to check your machine. You need to see what are the different dependencies for FFmpeg. So before configuration and compilation, do install all the dependencies. There could be a lot of dependencies depending upon the kind of codecs you want to use or the kind of platform on which you are compiling FFmpeg. So once you have installed all the dependencies, you have taken care of all the dependencies, a user can configure FFmpeg source code depending upon the requirement, the kind of codecs it wants to support. Like I've taken a typical example where I've taken enable libx264. So libx264 is an H.264 encoder library. So depending upon the usage, a user can configure FFmpeg accordingly. By using this, the footprint of the source code will reduce. So it again gives an advantage on saving the memory. So once the FFmpeg is configured, the FFmpeg binaries and libraries can be generated by giving a make command, which is a standard way of compiling on a Linux machine. So moving on to the next slide. We have seen how FFmpeg can be compiled. Now how FFmpeg is used by multimedia players. As we know that FFmpeg is hosted over Git, so there are multiple repositories which are maintained by different multimedia application developers. For example, let's take a case of mplayer. So once you try to check out or compile mplayer, so while doing that, mplayer checks out the latest FFmpeg source code, and while compiling, it compiles against the latest code. You can also configure mplayer, like in case you want to have a GUI. So you can use a parameter enable GUI, and you can have a graphical user interface. Again, based on the usage, codec libraries needs to be compiled and installed separately. Another very popular multimedia player nowadays is XBMC. XBMC in the code, checking out code from FFmpeg Git repo. XBMC maintains a copy of FFmpeg as part of XBMC repository. So XBMC can also be configured using external FFmpeg. Let's say you have your own FFmpeg in which you have integrated hardware codecs and you want to make use of them. So you can just compile XBMC by using a flag enable external FFmpeg, and the XBMC will make use of external FFmpeg which you have already compiled in your system. So in this way, it gives the flexibility to the user. So let us now see some use cases of FFmpeg. FFmpeg, there could be multiple use cases, but primarily I'll be covering two specific use cases. One is transcode and other is streaming. The decode and playback use case is kind of an implicit use case. So while transcoding, I'll cover decode and playback as well. So that is why I haven't mentioned it explicitly. So let us see how a multimedia transcode takes place. First, what is actually a transcoding? Transcoding is direct digital to digital data conversion from one format to another format. What is the need of doing a transcoding? Transcoding is usually done in cases where a target device does not support the format or has limited storage capacity. So with limited storage capacity, it becomes a compulsion, a mandate to reduce the size of the content. Or another scenario could be that the multimedia file, the codec supported by that multimedia file is incompatible, or it has obsolete data. So in order to convert it to better supported or a modern format, transcoding is required. So these are basically some typical use cases of why transcoding is necessary. So this diagram depicts a pipeline kind of an architecture used for transcoding. The input stream, it goes to the demuxer. What demuxer does is it extracts the elementary streams for both audio and video. The input stream is basically in the form of a container, so the stream contains an audio format as well as a video format. So what a demuxer does is demuxer extracts the elementary streams for audio and video from that container format. Then these elementary streams are fed to decoders. The audio and the video decoder, they handle the compressed elementary stream and outputs the uncompressed raw data. The raw data for audio is in form of PCM data, and in case of video it is YU format. There could be multiple types of this YU format like NV12, and same goes for PCM, it would be LPCM, or there are a lot of other formats. The raw format will consist of decoded frames, and it'll, in case of video, it will also have associated timestamps with all I, P, and B frames. The raw data goes to video post-processor. In video post-processor, certain processes like changing of bitrate, image resizing, motion adaptiveness, color space conversion, all these things takes place in video post-processor. Like in case of a decode and a playback kind of a use case, we don't need to have a full pipeline. We can work with a partial pipeline. The post-processed data is fed to the renderer. In renderer, audio and video sync takes place, and after audio and video sync, this data is given to multimedia application. The multimedia application then renders it on various output ports which are connected to that particular device on which that multimedia application is playing. Some typical output ports could be HDMI or I2S0, and in turn that HDMI could be connected to a television or to a music system. So in that way we get a playback using partial pipeline of FFmpeg. Now coming back to transcoding, the post-processed data is fed to a respective encoder. In encoders, the data is compressed into desired formats. The compressed data is then fed to multiplexer. The job of the multiplexer is to combine audio and video elementary streams into desired container format. Later in the slides, I'll show a live example of how FFmpeg does transcoding and what kind of command line options can typically be given. So this is basically a transcoding pipeline, how multimedia file format can be changed using FFmpeg. Moving on to next slide. Another very common use case of FFmpeg is streaming. Now, what is streaming? Streaming is a very popular technology by which multimedia content is delivered continuously from a server to end users. All of us watch videos over YouTube, so that is also working on streaming. So there could be a lot of different constraints which could affect the delivery of the content. One is network rate fluctuation. The bandwidth keeps on fluctuating. Sometimes it's good, sometimes it's bad. And it also depends upon the client, what kind of a device you are using to view that content. For example, let's say the end user device only supports a particular display resolution, or has a limitation on the maximum video bit rate, or can only play certain media formats, or has a CPU which cannot handle let's say an HD file. There could be other things associated with it, like power consumption. So in order to tackle all these constraints, we can use FFmpeg. Adaptive streaming technique is another good thing which can be implemented using FFmpeg. What it does is it addresses the problem of difference in data provided to different clients. This streaming protocol supports variable bit rates, and depending upon the bandwidth, it switches to an optimal bit rate so that the playback experience is smooth, the continuity is maintained, and there is no buffering or lag. One can also do media encryption and user authentication over HTTPS. With this, it allows the publishers to copyright their work, to protect their work. Moving on to next slide. The combination of FFmpeg and FFserver can also be used to provide on-the-fly transcoding. So on-the-fly transcoding means that FFmpeg can receive media input and it can convert this media input as soon as it gets it. So it doesn't need to wait for the entire media content to be downloaded onto the local disk. So the two main advantages which a user will get by doing on-the-fly transcoding is the user doesn't need to transcode the content in advance. It can do it at the runtime, and there'll be a lot of time as well as memory saving which will happen by using this on-the-fly transcoding technique. Moreover, there could be scenarios where a user would not want to tinker with the original content. So using this technique, the original content can be transcoded at runtime. So this is a very nice feature which can be implemented using FFserver and FFmpeg. So moving on to the next slide. So this particular slide depicts an example of how multimedia streaming takes place. So in this particular picture, there's a NAS box. Basically, it's a storage device. One can store the multimedia content on a NAS server. There could be multiple clients. There could be like a cell phone or a tablet, or maybe a laptop which is connected to this NAS device over internet, maybe over HTTP protocol. And we can also have a firewall so as to have an administration over the content as well as the users. Let's say we want to restrict one particular user to only a particular kind of a content. So firewall does all this picture, does all this purpose. So a user can maintain different copies of same content using FFmpeg, or maybe do an on-the-fly transcoding to save memory. And in order to maintain playback continuity, adaptive streaming can be done. So basically this gives an overall idea of how does a streaming ecosystem looks like. So moving on to next slide. So this is basically an example of adaptive streaming solution architecture. It will give you a good idea how adaptive streaming can be implemented. Adaptive streaming is a concept, basically. There are many techniques by which adaptive streaming can be achieved. Apple has its own adaptive streaming solution. Microsoft also has its own adaptive streaming solution. The solution which I have mentioned over here is FFmpeg. It is again an open source solution. So I've used this particular technique to give an overall picture of how adaptive streaming solution will look like. So in this particular diagram, you have a platform, you have a system on chip. This system on chip supports multiple hardware codecs. It also, for connectivity, it has a wireless network stack. FFmpeg framework sits on top of this particular platform. FFmpeg, it basically generates the content with different bit rates, different duration, and the kind of format the user would want the content to be. So FFmpeg does all this work. All the content which FFmpeg generates, it is then fed to FF server. FF server basically takes content in the form of FFmpeg feeds. It's a protocol for FFmpeg in which FFmpeg expects the content to be. It also maintains an indexing of all the content. So the indexing is done depending upon the format, depending upon the bit rate and the duration. So after doing all this, FFmpeg broadcasts its data. So there could be multiple clients retrieving the data in parallel. So the mpeg- client will be running on these devices which want to play this content. So based upon the available bandwidth, the dash clients require appropriate data from the FF server. So in case the bandwidth goes low, so the mpeg- client would request a data of lower resolution. So there will be slight degradation in the quality, in the viewing pleasure, but the continuity will maintain. A user will not have to encounter those ugly errors with respect to buffering and all those. So adaptive streaming solution takes care of all those requirements. So moving on to the next slide. So although FFmpeg it has its own server, FF server, but here I've mentioned most commonly used DLNA compliant digital media servers. So DLNA is again a very popular thing. So these are basically DMS which are DLNA compliant, and they are using FFmpeg. So I've tried to list free as well as proprietary digital media servers. So Twonky media server is from Packet Video, a very popular media server which has been used. Same goes with Allegro. The free ones are PS3 media server, University media server, as well as Plex. It is again a very popular free media server. So moving on to the next slide. So we have talked about digital media servers. Now here's a small list of digital media players. DLNA compliant media servers would require DLNA compliant media players. So here's a list of DLNA compliant multimedia players: XBMC, VLC, Boxy, Plex. These are all very widely used digital media players. So moving on to the next topic in the agenda, which is integration of hardware codecs. In this particular section, I'll present 3 different approaches by which, depending upon the architecture, an application developer can leverage hardware codec capability. So the first use case that I have listed over here is, let's take an example that there's a platform which has hardware codecs inbuilt. So how an application programmer will be able to use those hardware codecs? The application programmer would want to use those hardware codecs so that it can leverage the it can leverage those dedicated hardware decoders. The CPU usage goes low, better performance is experienced. So what could be a typical implementation approach? Traditionally, FFmpeg comprises of software decoder libraries. So hardware codec APIs needs to be integrated into FFmpeg framework. Once these APIs are integrated into FFmpeg framework, the applications which are making use of FFmpeg libraries will be able to use the hardware codec instead of software codec, and in turn they'll be able to make use of underlying hardware. So what are the advantages that a developer would get? All the decoding work will be offloaded to hardware codecs. So this will save a lot of CPU bandwidth. So this CPU bandwidth can be used for some other purpose. The next example is playback using libvieh and FFmpeg. So video acceleration API or libvieh, it is basically a library and an API specification from Intel, and with this one can enable and provide access to graphics hardware, or what we commonly call as GPU. So in the earlier example, the platform which the user had hardware codecs implemented. Now in this particular platform, the user has a graphics GPU. So the implementation approach will be like, instead of hardware codecs, now FFmpeg can be integrated with ViA API, and the ViA API will communicate with the ViA hardware drivers, and by using ViA hardware drivers, it can use the GPU for decoding and encoding. A very good example of how ViA API is being used is XBMC. The XBMC player can be configured to use OpenGL ES, and the OpenGL ES is integrated with ViA API for embedded platforms. So in this way, FFmpeg can make use of ViA API to leverage hardware capabilities. So what are the advantages that one would get by using this particular approach? So this will provide application and access to hardware video decode engine, resulting in enhanced user experience and greater CPU bandwidth. As the decoding work is now being handled by GPU, so again the CPU utilization goes low. The third example here is playback using Gstreamer and FFmpeg plugin. As I said earlier in the presentation in this webinar, that Gstreamer is the other multimedia framework which is very popular. Now let's say there's a use case that the multimedia player like Totem Movie Player or Rhythmbox is Gstreamer based. So it is running on a platform which has hardware codecs. Now it want to leverage those hardware codecs. So one way of doing it is we can integrate those hardware codec APIs into FFmpeg, and then FFmpeg can be integrated into Gstreamer as a plugin. In that regard, Gstreamer is very flexible. It gives a plugin architecture. So by doing this, it enables the application to make use of hardware decoders. So with this approach, the players which are based on Gstreamer would also be able to leverage the hardware capability. So moving on to the next slide. So here I have listed down what are the most common issues which developers face while doing integration of hardware codecs into FFmpeg. So usually hardware resources are not available. The target platform will only have specific kind of hardware codecs. Now let's take an example. If a user wants to play a content which is based on a codec which is not supported by that particular platform. So in spite of you integrated hardware APIs into FFmpeg, user will not be able to see the content. So there has to be certain kind of a mechanism needs to be implemented into FFmpeg, where FFmpeg checks whether that particular hardware codec is available or not. In case that particular hardware codec is not available, then there should be a provision of software fallback, as most of the software codecs are supported by FFmpeg. So by doing so, multimedia application would be able to play a content using software codecs, but the performance will be degraded. So that is the consequence of using the hardware codec. Another scenario could be that a user wants to do a playback and a transcoding simultaneously. But in that particular scenario, the hardware resources are limited. We cannot open multiple instances of a hardware codec. So in that case also, there should be a mechanism where FFmpeg does a fallback to software codec. So by doing these kind of techniques, there will not be any error. So it will be a robust system, and a user can be informed that FFmpeg is using software codec, so the performance will be slow. Another example of what kind of issues developers usually face is like architectural differences. In a typical Linux kind of environment, device drivers of hardware codec are in kernel space, whereas FFmpeg library is in user space, and the plugin which a developer will write will also be there in the user space. So there will be constraints when the decoded data is copied from kernel space to user space, and in case of an encoder, the YUV data is copied from the encoder plugin to hardware encoder. the YUV data is raw data. So in comparison to compressed data, this data is huge in size. So a lot of CPU utilization goes in this copying. So this affects the performance. A user might face audio video sync issues due to these kind of architectural issues. So a developer should be careful while designing their solution. So now I'll present few live case studies where by using hardware codecs it resulted in better CPU performance as well as better frame rate. So the first example is, the user is trying to do a transcode using software libraries. libx264 is a software S.264 library. So as you can see, the frame per second is as low as 8. So this will take a lot of time to transcode a 1080p file. So moving on to the next slide. In comparison, when a user tries to do a transcode using hardware codecs, so the same multimedia content, for same multimedia content, the frame per second is as high as 51. So this gives you a comparison of how much the performance has improved by using hardware codecs. Let's take another example. So in this particular example, I'm trying to do a playback using a multimedia application called as FFmpeg. So when I try to do a playback without using hardware acceleration, the CPU usage goes as high as 99%. So in this particular scenario, you cannot perform any other job as CPU is totally consumed while doing a playback. Now let's look at a comparative study where FFmpeg uses VA API. So in this particular example, the CPU utilization is as low as 10%. So this gives a comparative study of what would be the CPU usage typically if you use hardware acceleration by the API. Now let's look at another example. In this example, I'm playing again a 1080p content using XBMC, and this is without hardware acceleration. So in this particular content, the CPU usage is as high as 95%. Whereas if I play the same content using hardware acceleration, the CPU usage goes low to around 30%. So this is the kind of advantage a user will get by enabling the hardware decoders and hardware acceleration. Another example is, so here it gives a command line statistics of the performance. So here you can see the video codec usage is as low as 26%, and the audio codec is just 1.4%. So in this, the CPU usage is again changed. So that's all from me on this presentation, on this webinar. So if you have any doubts, please feel free to ask. Just let me look at the questions. So the first question is from Vikas. He asked, do I mean to say that application is independent of multimedia framework? Over here, what I'm trying to say is that the multimedia framework should be independent of application, which is using that multimedia framework. An application has to use one or another multimedia framework to support codecs. So an application cannot be independent of multimedia framework. The next question from Vikas is, and if an application developed over one framework will work on another. So in this particular scenario, the app developer needs to see how he's configuring that application. Different multimedia framework have different architecture. Like Gstreamer has a plugin architecture, while FFmpeg does not. It has a modular architecture. It supports incorporation of different codecs. So this is something which an application developer needs to take care of while designing the application. So the third question is from Swaraj. He is asking, what is the difference between .NET platform to open source platform, and also FFmpeg. I'm not much of a .NET guy, so what all little comparative study that I've done is on Windows and open source platforms. So Saurav has asked how FFmpeg supports streaming. FFmpeg supports streaming by using FFserver. So there is a configuration file which you can make for FFserver. You can specify the format of the content which you want to stream, the duration, the bit rate, all those metadata you can configure in that FFserver configuration file, and in turn it can be used for streaming. So another question which Saurav was asking, what is SDL? SDL is nothing, it's just a display library. So the other alternate of display library could be Xserver, or it could be embedded media graphics library supported by Intel. So it is just a way to render the data onto the screen. So moving on to other questions. So Prabir Das has asked, how can I get RPM codec for multimedia? There are a lot of different codecs. So I'm sorry, I'm not aware of RPM codec. What does this RPM codec does? So maybe if you can just send an email to me, I can probably look into it and get back to you. Ravindranath Vanrang has asked how to integrate it with a Beamer, PPT and analog of latex. So probably if Ravindranath can send me an email on this, I'll be able to give more insight of how to do it. Ashish has asked what kind of parts are covered by FFmpeg as part of GPL. So basically, while configuring FFmpeg, you can give a configuration parameter, whether you want to configure it as LGPL, whether you want to configure it as GPL. And on the basis of those configuration parameters, the code which is specific for GPL, only that will get compiled, and the code which is specific for LGPL, only that will get compiled. So if you're looking for specific modules which are under GPL and LGPL, I will advise you to just do a grep and you'll see the source code which is under GPL and which is under LGPL. Other example which Ashish is asking us is RDSP support in the latest FFmpeg version robust enough? So Ashish, over here, most of the work that I've done it over HTTP. So I've not really did a comparative study. How does the streaming, what kind of performance once we do it for over RDSP or an HTTP. So that's probably an action item on me. So if you can just send an email to me on this, probably I'll be able to give you better insight. The other question which Ashish is asking, what could be the pros and cons of using FFmpeg over Gstreamer framework while developing a new media player solution? So in favor of Gstreamer, Gstreamer has a plugin based architecture. So it is actually more of a decision of a developer, what a developer is more comfortable with. The architecture of Gstreamer is quite well documented, so probably you can get a lot of support and documentation on how to write a plugin for Gstreamer. So that is like in favor of Gstreamer. In favor of FFmpeg is that FFmpeg supports whole lot of software codecs. So there could be a possibility that a certain codec is not supported by Gstreamer, while that particular codec is being supported by FFmpeg. And the consequence of using FFmpeg could be the FFmpeg architecture and the way to integrate hardware codecs is not something which is generic. It is something which could be specific depending upon the APIs which that particular codec has to offer. So one really needs to dig deep and understand the FFmpeg source code and integrate the codec. The question which Bhavesh is asking, does Dash supports various resolutions? In concept. So basically Dash doesn't have to do anything with various resolution. Various resolutions are generated by FFmpeg by doing transcoding. Dash is just a streaming protocol which decides based on the indexing done by FF server that which kind of a content one needs to transmit. Prashant wants to ask us how FFmpeg is used in Android So I believe the multimedia framework in Android has stage fright, so you can probably integrate FFmpeg into stage fright and can use hardware decoder. Lakshmi ran was to ask what is OGLES. So there are different graphics components in Linux. So OpenGL is a very popular graphic component which is being used by different applications for rendering. OpenGL ES is OpenGL for embedded systems. So this is a specific implementation which is being designed for embedded systems. So Manoj wants to ask regarding the coding examples for FFmpeg. So probably for that I'll request him to send an email to me, so I can probably give him some code snippets to have a look at the FFmpeg. Yogesh wants to ask us, can we use parallel FFmpeg command for parallel transcoding of multiple files on a single Linux machine? So this would, in theory, yes, you can do it. If you are using software codecs, this should not be a problem. But if you are using hardware codecs, then there could be resource crunch. So while designing your application, you need to take care how many resources are available to you, and on the basis of that, FFmpeg can do parallel transcoding. Gurvinder wants to ask how FFmpeg can help in developing iPhone app. So I'm not really sure how Mac OS architecture is, but there should be a way of integrating FFmpeg with the multimedia applications, and then you can leverage all the capabilities that FFmpeg has to offer. Again, VZ Gachi has a similar question. Like how can FFmpeg be integrated with iPhone app? So I'm not really a Mac OS guy, so I really don't know the internals of it. V. Kumar wants to ask, how can a hardware acceleration be used on ATI 7000 series GPUs? I'm not familiar with ATI 7000 series GPUs. I've done hardware acceleration support on GPUs provided by Imagination. So on that it works really well. Arindam wants to ask, is there any open source component available for OpenMax? I'm not sure of this. I'll request Arindam to drop an email and probably I can check and get back to him. Yogesh wants to ask, how can we use live TV channel feed using FFmpeg and stream it to users? So Yogesh, this is where on-the-fly transcoding comes into picture. So you can just take that stream and FFmpeg can feed it to FF server, and in turn FF server can broadcast it to all the other users. So in this scenario, so you need to, all the clients which are trying to see that feed should be aware of the URL on which the FF server is broadcasting that particular content. And I believe with this it should solve the purpose. Arindam wants to ask, does FF server supports bit-rate switching during RTP streaming? Does it supports bit-rate adaptation based on RTCP loss in information? Basically on the server side, no switching happens as of. It is a job of the client to make sure what kind of a bandwidth is there on offer. So based on the bandwidth, the client needs to fetch that particular content depending upon the bit rate, which can be transmitted smoothly. So most of this decision making is done at the client's end, not at the server's end. Jahan wants to ask us, he's from Windows background, so he wants to ask which codecs are supported for Windows. So I think for software, almost every codec should be supported. Winamp and all these players which are based on Windows have a list of all the codecs which it supports. I'm basically not a Windows guy, so I'll not be able to give a good answer to this question. So you probably need to go to a Windows guy to get a better answer on this. So are there any more questions coming, or we are done for the session? So I'd like to thank all the, we have another question, yeah, from Bhavesh. How do we verify FFmpeg segmentation on iframe boundary for MPEG to transport stream package? So Bhavesh, on this session, I'm not really going into the insights of video compression. So I can definitely help you on this. Please do drop me an email so I can get back to you on how this can be done. So AVS and Murthy wants to know, are there any enable tags? I think he wants to say enable flags while compiling FFmpeg to enable hardware codec. So as I said, FFmpeg is basically a library which is meant for software codecs. So if you are integrating your own hardware codec, you need to change the configuration option. Like in the example which I have taken, you can see the configuration option which I am giving is h.264_hardware. So you need to change the configuration options. Whereas for VAPI is a standard library which is open source. So there's an option to enable disable VAPI. So Vinkush also wants to know which commercial hardware are available for hardware codecs other than GPUs. Winkle, what I have worked on is I have worked on GPU as well as hardware codecs which are part of SoC. So other than that, I'm not aware. How can we, Surbhi Mishra wants to know, how can we test our contributions to FFmpeg? From where to get test samples? So I'm not sure if I really understood this question. So there are a lot of websites where you can download test content depending upon different bitrate, different resolution, different file formats. So you can just try to play those test content using FFmpeg. Basically, also you can do a transcode or try to play back using any of the multimedia applications which is using FFmpeg. If you mean something else, probably you can just drop me an email. So Pradeep wants to know, AV Foundation framework uses GPU in iOS, then how it is different from FFmpeg. So again, I'm not a Linux guy, but what I understood from this question is libavcodec is one of the libraries which is supported by, which is like part of FFmpeg. But being open source, there are a lot of different developer groups which are maintaining their own versions of it. They have done their own customizations of it. So it's a free software, and anyone can do their own customization. So I'm not really sure what changes they would have done from a standard libviv codec, which is part of FFmpeg. So I hope this answers all your queries. Are there any more questions?
Well, those were the only questions we had, Mr. Sangal. Thank you so much for the insightful presentation. I'm really thankful to you for conducting this webinar.
Thanks a lot.
It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this session would be available on techgeek.com by tomorrow. Thank you all. Have a great evening.